the potential roadblocks to sustainability. The first one is pretty obvious when you think about it. Who wants to pay more for something than they have to? No one. Living sustainably may cost more, particularly up front. What we believe is that living sustainably will actually cost a lot less in the long run, but getting there is the problem. Changing over to brand new technologies is the problem. So there are a lot of costs that go along with sustainability, and some people view that as a really big roadblock. Why should I invest in this new technology that will save me money 50 years from now if it's going to cost me that much more today? Then there's this idea of risk analysis. Is there a potential hazard with this? Is there just a perceived hazard with it? Does it make sense to assume that something bad will happen? And the way that we handle risk analysis, there's risk built into lots of things, especially with money. And you have to evaluate the potential hazards of things before determining whether or not they're actually a problem. There is a kind of recall of romaine lettuce in Canada because it's causing E. coli infections. In the United States, there have been problems with E. coli in 19 states. We haven't definitively linked it to romaine lettuce, but that's what everyone believes it's linked to. We have not yet recalled it because it hasn't met our threshold for what our FDA uses to determine whether or not we should alert people to not eating romaine lettuce and not purchasing it. Because E. coli, the main way to kill it is to cook things. And does anyone in here eat cooked romaine lettuce? Because that kind of defeats the purpose of crunchy lettuce. They have a very different threshold for what they use for determining to give a consumer alert in Canada than we do. And that's based entirely on how they do their risk analysis. For sustainability, if you want to say that a problem is actually caused by humans, you need to be able to prove it, particularly if it's going to cost people more to fix it in the long run, or if there's a risk attached, you need to be able to prove that it's anthropogenic. Anthropogenic meaning that it is related to human activities. Or is it natural? A lot of things we're going to talk about in some level have aspects of both. We're not always going to have enough knowledge to give people everything they want to know about a topic. Coral reefs. Would you say right now that they're healthy? Some of them. Most of them, no. But if somebody wanted to know, well, how much longer do you think they could continue living under the current conditions we have today? The best somebody can do is give you an estimate. We can't really have all of the information available. Has anyone here ever bought a car? But you all decided where to go to college, so we'll pick that one. You had some knowledge about your decision choices. You determined what your cost was. You went through some sort of a risk analysis in your head. Was this worth it? Was it not? A cost-benefit analysis at that point. But did you have all of the information you wanted to know about the college before you decided where you were going to go? Probably not. You had enough to make an educated decision. Policymakers tend to want more information than we can sometimes give them about an environmental situation. So we have to think things through well. And then we have our cost-benefit concept. How much is a gallon of clean water worth to you? How much would you pay to buy a gallon of clean water?
I paid 89 cents for a gallon of water.
Would you have paid $1?
Yeah, I think I would have paid that.
Would you have paid $5?
No, when they have one for 89 cents.
Exactly. I'm wondering where this comes from is the idea that we frequently have to put a monetary value on environmental items or services or products in order to do a cost-benefit analysis. Andrew, do you fish?
Yes.
Would you say that having clean water in lakes, bays, oceans is important for fish?
Yeah. Everything else.
One of the ways they tried to calculate the value of clean water in the Chesapeake Bay a number of years ago was by determining how much money fishermen spent on licenses for fishing. But there's a lot of things wrong with that because they forgot boat rentals, parking fees, boating license fees in some areas, boat registrations, hotel fees, campground fees, all these other things that people that are fishermen pay. But it neglected to also include the people that come to the Chesapeake not to go fishing, but to go swimming or for going down in that area. So there was this metric that somebody was using based entirely on what fishermen would be willing to spend to fish there. But they overlooked everything else. They were trying to figure out whether or not it was worth making the water cleaner. Would it actually provide more revenue in cleaner water because there would be more fish for fishermen to fish? For some of you, this is a really uncomfortable way to think of an environmental problem. That we put a cost on it, and then we determine whether or not it will actually return money in the end. Some of our decisions are made this way because we have to have a way to make them. And now we're going to switch topics entirely. We'll come back to these ideas multiple times throughout the semester. How big is the human population? Well, let's check the population clock. I tried it down when I checked it last week. 7 billion something. I think it's like 7.4 or 7.5. So we have the world population is 7,446,901,057. Oh, wait, 64.5, and it keeps growing. The U.S. population is 327,026,170 right now. We're the third most populous country. We have one child being born every 8 seconds, one person dying every 10 seconds. And you can drill down, if you want, further into the data. You can look at population by regions, by gender, by age group. All sorts of things are available on the census website looking at population clock data. We add, depending upon which website I used to get this information and or your textbook, we're adding between 75 and 85 million people every year. But more people means more food, more water, more space, more houses, more schools, more jobs, more money, more clothes, more items, more computers, more cell phones, increased use of energy, and more topsoil in order to do more agriculture. Is there a problem here? Can we make more? Can we create more jobs? Yeah. Can we create more cell phones? Sure. Can we create more topsoil? To a point. Can we create more water? Yeah. There are ways to potentially try and get more water in liquid form on the Earth's surface. It's usable, but it's difficult. Can you think of anything else that more people means more of? More food?
Waste.
More waste? Noise pollution? Crowding? Do any of you get really uncomfortable in like very crowded places? More and more people is going to be more of that. And unfortunately, the areas that are adding more people faster I know you've all seen graphs of exponential growth before. Do these look like exponential growth to you? What's the other type of growth curve these could be that are not yet? Exponential growth will frequently go into another type of growth. As it approaches carrying capacity, it becomes, make an S curve. Does anyone know what we call that kind of growth? Logistic growth is where we're going to hope to get. So this is exponential, and this is the world right now, and this is the United States right now from about 1,800 populations. Kind of looks exponential. Eventually, we're expecting something like that blue graph, a carrying capacity, because it will go then into a logistic growth curve. For there to be a logistic growth curve, there has to be some form of a limiting factor, because exponential growth continues until a resource becomes limited. However, we don't have the same problems with resource limitation as do animals and plants, because we are able to manipulate our environment to draw more and more resources from it. So that is probably why the human population has not reached its carrying capacity. And can anybody define carrying capacity for us?
I mean, in this circumstance, I guess it would be like when we hit the amount of people that we can feed and house, and then when we succeed that, I guess that would be when we experience a crash.
Yeah, so it's the amount of individuals that an ecosystem can support for a long period or an indefinite period of time. Population will crash when you exceed those limits. There are, I think I know the answer to this, but I'm going to ask anyway. In ecology, did you guys do any population modeling?
I'm going to talk about it a little bit.
But not, okay. My ecology professor in undergrad did a lot on population models, and he had us run simulations. And one of the simulations we ran brought up the idea of chaotic population models. You could only pass the entire assignment if you passed the assignment on chaotic models, I believe, which sounds a little crazy, but it was really to see if we had any logic in our brains whatsoever. In a chaotic population model, at a certain point, your population goes negative. At that point, you're supposed to stop your population model because your population has gone extinct. About a third of the class did not, and they brought their population back from the dead. My ecology professor was also the advisor for the University Christian Fellowship where I went to school. So he thought it was really interesting that he got to talk about resurrection just slightly as part of a lecture at a state school. But he was like, what did you guys do? How did you like resurrect your species? Like in a chaotic system, they go extinct. And in that, it's usually that something outside of the resources and outside of the population has affected it, like a flood, like years of extreme drought or something like that, and the population has been driven to extinction, or disease or something like that has popped up. We won't be talking about those, and the book that we're using for this doesn't include them, but there are other types of population models that are really not predictable, whereas logistic growth you can eventually, if you know the resources, you can model and predict a carrying capacity. What do you guys think the carrying capacity of humans is? We're at 7.45-ish billion right now. By the way, I've been teaching at Eastern now for, what is this, year 6 or 7? Year 6. We reached 7 billion people on the planet while I started teaching at Eastern. So we've increased by that almost 500 million in 6 years. The doubling time for the Earth right now, we expect population doubling time is about 45 years. Anyone think our Earth can support 15 billion people? Anyone think it's 3? There are lots of ecologists that talk about how we overshot our carrying capacity many, 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 many years ago. But then we're going to see that some of those things get a little tricky because there are very few ways to get your population back down to that level unless you let people die or you kill them. If you're wondering, are there scientists that have suggested that the best way to handle the world's current population crisis is to kill people? The answer is absolutely yes. Can we all agree that that is not a plan? They're like, famine could be good, then people die, and we get a lower population. I think they're wrong. I tried to pick our book for this course as the textbook because it doesn't go there. I had a book a number of years ago that said that the best way to deal with population control was through abortion. Like, they were like, this should be considered as a way to handle population control. And I was like, I wish I'd have read that chapter before I picked it, because is that a way to handle population growth? Or better question, is that an ethical way to handle population growth? Neither is famine or releasing a disease that will kill lots of people. Things that have been thought of, usually not talked outside of many circles, but there are publications out there, if you look, where you can find scientists that have argued for abortion, murder, famine, genocide, diseases as being good things. These are not usually scientists that are seen as good people or to have had good ideas, but they are out there as a way of trying to get us back to whatever our magical carrying capacity number is, because we don't know what it is. Maybe it is 15 billion. And if so, we're good for like another 50 years.
Do we know what it would look like for the population crash? Like, would it be something like what the Earth is currently experiencing, you know?
Could be.
Food shortages and all that stuff?
It could be. We expect it will be a little bit worse than this. But the problem might be that we can kind of insulate ourselves from it. We can protect ourselves from it. So if it would be disease that would take us out, well, we can create medications. We can vaccinate. We can do all of these things to keep ourselves healthy. We can remember to like wash our hands with soap and water, which is like the bare minimum. We can also create food. If we run out of areas to grow food, maybe we can do hydroponics and we can do other things. And we can create nutrient-dense foods in the lab entirely.
For the carrying capacity, I'm just wondering how like inequality of like wealth distribution plays into that, because like right now, some people are starving and some people are overeating and like that kind of thing, like wealth and poverty. If like, I feel like we wouldn't be at carrying capacity if we consumed less, and like we could still live good lives while consuming less. But I don't know if that's, maybe you hit a point where everyone is consuming less, but the population is like higher. Would that be like the crash?
That's part of the problem with calculating carrying capacity.
Yeah.
Is what we can do in the United States versus what somebody can do in sub-Saharan Africa or in Indonesia is very, very different. We're not living on $1.25 a day. So we have the ability to do those things. In a lot of places, people are dying because they don't have clean water. I don't think that's not going to happen to any of us today. And that is one of the biggest problems with human population concerns, is that there is an inequality. And that makes it a huge justice issue. How do we deal with the fact that there are people that have nothing, and there are people that could never want for anything? Because then you start talking about wealth distribution. Completely relating that to food distribution for a lot of people becomes very uncomfortable. But it's very true. This graph is a crash of the reindeer population from St. Paul Island in the Bering Sea in the 1900s. In 1910, they introduced 26 reindeer to the island. 24 of those 26 were female. By 1935, so in 25 years, there were 2,000 reindeer. By the 1950s, there were 8. Not 8,000, 8. That is a population crash. 26, 2000, 8. What do you think happened?
Not enough food, not enough space.
Not enough food. Is at 2000, they're eating so much food. There's no predators. There's nothing to keep their population in check. They're utilizing all of their resources, and then suddenly there's not enough, so a whole bunch of them starve to death. And then the food starts to grow back, and the population can start to increase a little bit. On St. Matthew's Island, we actually were able to track this in 1944. There were 29 reindeer. They were brought there as a food source for the Coast Guard that was stationed there because they were afraid that they would somehow get caught up from their food supplies during World War II. That was why they brought the reindeer to these islands. The island was a whole 32 miles by 4 miles. And by 1957, they had 1,300 reindeer. By 1963, they had 6,000 reindeer, and that worked out to 47 reindeer per square mile. Per square meter. Think about a deer. Would a deer be able to survive on 40, would you be able to have 40, it was 47 reindeer per square mile. Would you be able to have 47 deer per square mile and have them have enough food? Then think about how much larger a reindeer is than an actual white-tailed deer. 1966, there were 42 left. So in 3 years, 6,000 to 42. The population crashed. Within 10 years, they were all gone. When they went back and they investigated, they discovered the winter of 1963 had been really, really bad. Very cold, not much food, and they froze and starved to death. Not enough shelter, not enough food. There was so little food that the ones that survived by feeding on lichens, which is not the normal food supply for deer. So we're exponentially growing because we don't have to, in most countries, worry about freezing to death. We go inside our homes, we turn on our heat, everything's good. We have machines that help us do agriculture better. We have technology that allows us to do everything. We can live just about anywhere on the planet. Just about anywhere. We can live in Antarctica. We can live in the Arctic Ocean if we're on boats. Can we live underwater? Yes. There are research stations that are underwater where people can spend up to about 3 weeks seems to be the maximum that we allow them to spend there, because you start to be concerned about health after that. But you can spend about 3 weeks completely submerged, where you are using scuba when you're not in the habitat, but when you, one of them is just south of the Florida Keys in Aquarius. Another is off the coast of Belize, I believe. So there are a few different research stations like that. So we can, we believe, eventually colonize the seafloor to a certain depth limit, of course. There's modern agriculture. We can grow food anywhere. We grow food in the desert all the time. It's a bad use of land. It's a bad use of water, but we do it. We have great health care. And then we have the problems that Emma brought up. There's no equal distribution. In 2012, out of 80 infants, 1 was born into what's considered a more developed country. The other 79 were born into less developed countries. So most of the people in the world live in less developed countries. In case graphs help you think better, we see that the population has risen significantly in the less developed countries compared to the more developed countries since the 1950s. A lot of this has to do with increases in modern medicine and better distribution of modern medicine. There's math involved with this. Your population change is equal to your births plus immigration minus your deaths and emigration. You can calculate a fertility rate. If it's a stable growth, your fertility rate is 2, that each couple will produce 2 children. They're just replacing themselves. When it's more than 2, it means they're having more children than replacing themselves, so it becomes a lot larger. You find that this is a relatively low number, 2 or under in most of your more developed nations. It's low. It's very high in your low developed nations. There are some nations in Europe where they actually have a negative population growth because they are having fewer offspring than there are adults. And some of them are trying to figure out how do they increase their population size, because eventually they will have so many people that are elderly, they won't be able to potentially support themselves. And life expectancy is growing along with the population. In 1955, the average life expectancy in the world was 48. In 2012, it was 70. In more developed nations, it was about 80. Have you guys seen diagrams like this before? It's these age structure diagrams. You can look at male versus female, and you can look at pre-reproductive ages, which we cut off at about 14, even though you're probably all well aware that a 14-year-old could have a child. 13-year-old could too, but we consider 14 to be our cutoff for pre-reproductive. Reproductive ages of 15 to 44, and post-reproductive age is 45 and above, even though people in their 40s still can have children. Those seem to be the numbers that we use for these. In a country that is stable, you find that there's similar amounts of people in pre-reproductive as well as in reproductive, and slightly fewer in post-reproductive age groups. If they're growing, you're going to find that pre-reproductive is very large. If they're shrinking, you find that the post-reproductive is very large. So if you examine people based on these cohorts, you're able to figure out whether or not population growth is happening. And as you grow your ecological footprint, we deplete non-renewable resources, obviously. But we're also affecting our renewable resources. Renewable resources we might not be able to use up, but it doesn't mean that we can't degrade them, destroy them in some way, or disrupt their processes. They regenerate, but they don't always come back the same. They're subject to pollution. They are subject to misuse, to poor management. Topsoil. Is it important? Can it be eroded away? Then it goes elsewhere, and then it's no longer functioning there? Absolutely. So it doesn't leave the earth. It's just not where it was, so it can't perform its function anymore. So it has been disrupted from the system, or it's been degraded. Or we can use it so much that we deplete it in so many nutrients that it's no longer going to grow the same amount of food that it otherwise should. Water. We'll talk about water pollution this semester. We pollute it all the time. Most of the medications that we use, our bodies never process all of them. We actually, the doses that you're given are slightly higher than what you actually need. So the rest of the medication is usually flushed from your system with urine. And when that happens, it's put into our water, our wastewater. And our wastewater treatment plants lack the ability to filter out, to destroy, to bacterially break down antidepressants, caffeine, antibiotics, birth control pills, anxiety medications, things like that, blood pressure medications. They all stay in the water in low amounts. We're finding that that is leading to changes in gender distributions of protists, of crustaceans, of fish, It's leading to, they're called gender benders, a number of them. It's leading to a process known as feminization, where species are becoming more and more female and less male, which you all have had some biology, you know eventually that's going to become a problem. There was an article just this week that was about rising temperatures in the Gulf of Mexico, leading to the feminization of green sea turtles. But there are so few males now that the concern is that the population might not go extinct because of plastic trash in the ocean, but because sea turtle gender is determined by temperature during the middle third of, so during like that second trimester of their development. And it's determined by the hottest temperature of the day. And if it's too hot, they all become female. That becomes a risk. So we can hurt our resources. Some of them take a long time to hurt, though. And some of them we really can't probably do very much to. It brings up this concept of overexploitation, the idea that we're using things at a higher rate than they can be replaced or that they can clean themselves. How many of you know what the tragedy of the commons is? Your book gives, I think, a little bit of a summary about it. The paper in Science from 1968 is really short, so if you have a chance to find it and read it, it's pretty interesting. It's by Garrett Hardin. And the concept is this. We have a large field. You all own sheep. We all own 10 sheep. And one day, Hannah says, you know, there's enough grass here. I'm going to buy 2 more sheep. And then Andrew goes, she bought 2, I'm going to buy 3. And Elizabeth goes, I'm going to buy 5 more, and so forth. And then what do you think eventually starts to happen to this area where all of our sheep graze? Starting to get overgrazed. So suddenly we're all getting less money for our sheep than we got originally. So then we're all having to try and keep up with each other by buying more and more sheep, and eventually is the grass still there anymore? Not really. None of us owned the property, so none of us had the need to protect it because we all got to use it for free. So none of us invested in protecting it. When something is freely available to everyone, the odds of it being able to be destroyed are pretty high because we don't see it as happening quickly. We don't notice it until it's usually too late, and the resource is seen as unlimited and there's no need to protect it. It's a common area that is destroyed through the actions of everybody, not recognizing that they're doing something that could be a problem. This concept will come up as we talk about population, yes. We talk about agriculture, we talk about overfishing, overfarming, water pollution, energy usage. All of these things relate to this concept. What happened here? Let's hear some guesses. This was in Thailand.
Probably drought and deforestation.
Tropical deforestation is correct. So you cut down the trees, and it's going to then decrease the amount of water vapor that is held near the Earth's surface. It's also going to increase the amount of sunlight that then starts to bake the topsoil. The soil is going to start to get loose because the roots aren't there to hold it. It's going to start to erode away. So you're dealing with erosion, warming of the ground, and loss of soil moisture all at the same time. And eventually this happens. What you're seeing there, the lighter brown areas with the dark brown around them, that's the cracked topsoil that's left. Why do we usually do deforestation in a tropical area?
Get farmland.
Does it seem like it works?
Get lumber. No, it doesn't work.
Most places it doesn't, because that topsoil is only really healthy because of the ecosystem that's in it. Once you start removing that and you replace it with another type of crop, that soil doesn't function well because it's not meant to grow that crop. There's a concept of an ecological tipping point, and it makes me very uncomfortable. So if it makes you uncomfortable, we're in the same position. It's the fact that at some point in time, you get to a precipice, and when you go over it, you can't go back. So meaning that we can destroy something so much that we can't bring it back. So with that forest, what do we do? Do we try to bring things back?
I wonder if you can't bring it back the way that it was, if people are going to have to start thinking of ways to adapt to it and evolve, like, I guess just adapt, like, you know, like, if the climate is totally different, the ecosystem can't be as it has been, but maybe it can reform into something that can live in the new climate.
It's part of the concepts around restoration, is the idea that even if I can't bring back what was there, maybe I can bring back something else that serves similar services or that otherwise does something good. If you can't get back to where you started, can you at least get something back? There was a chance. Elizabeth and Tasha, are you the only two that have read the article on tuna? Probably, because we did that last spring. Okay. There's an article that those of you that take environmental policy, regulations and policy will read. I think it's in that one. It might be in marine biology. I forget which class it is. That's about tuna fisheries. It might even be both of them that we read it in. There was going to be a crisis about tuna in the South Pacific because these small island nations that owned like 90% of like the tuna hunting grounds were realizing that they were underselling each other to get people to come and fish in their waters. One day they all sat down and they decided they were actually going to not undersell each other. They were going to change the way that the tuna fishing business is done, and that countries that wanted to come and fish there for tuna had to come and pay whatever they demanded and work by the rules. Otherwise, they were going to be excluded from hunting tuna at all. They were afraid that the tuna would go extinct. They didn't want to have an ocean without tuna. What do you think happened?
Go somewhere else.
It would be nice, but the people couldn't go someplace else. Well, they could. 90% of the waters for tuna in that region of the ocean, they controlled. Some people came in and did it anyway. Some people went to that other 10%. Almost all of the countries got with the program. And they were like, okay, we'll do whatever you say because our people can't live without tuna. They're making more money. The tuna population has increased significantly. And they now realize that their people are going to have not only tuna, but jobs in the future, maintaining the tuna industry. It's amazing. They were able to divert it by changing how they did business. And people were willing to pay slightly more. Can we adapt to a climate that's different? Maybe we can. Or we're going to have to learn how to adapt to things. We can measure the impact of countries on the environment by looking at population size, wealth or affluence, and technologies. So your impact is usually some metric combining population size, affluence, and technology. And this is one other population model for us for today. Last population model. This is looking at a concept known as a demographic transition. Is anyone familiar with that phrase? So we have everybody in our pre-industrial time period. During pre-industry, population growth is pretty slow. There is a high birth rate, but a lot of people die very young. And a lot of people die in general. Lots of infants die. So there's not a large population growth. Then you increase food supplies, and you start to increase healthcare. As you do, fewer people die. They live longer. More children survive. So your population starts to increase dramatically. And then at some point, your birth rate starts to drop. People go to school longer, they stay in school, they get other jobs, they leave farming and they go into other industries, they have fewer children, and the birth rate has dropped. In post-industrial time periods, we expect that the population rate is going to decline as your birth rate falls lower than your death rate as people have fewer and fewer children. Some countries are in post-industrial. Very few, and almost all of them that are in Europe. Where are we?
Well, the one models had US in the slowly expanding category, but I would feel like the US fits industrial, the industrial stage more. So, well, I guess it makes sense because it says it slows. So I feel like
We're probably we're probably in 3, but probably not much more beyond 2, simply because of a lot of issues that we have as a country and different people's ways of living and doing things, and also our immigration. Do you think there's a lot of countries, though, that are probably in stage 2? And we call this movement from stage to stage the demographic transition. That your population is going to change its structure as you change through these stages. This one is not a shock for most of you that I'm probably going to talk about this, but research shows that one of the number one things that we can do if you want to slow population growth, believe it or not, is to educate women. In general, in this world, women are not educated well. 2 out of 3 adult women are illiterate, and 2 out of every 3 illiterate adults are women, and 7 out of 10 people living in poverty are women. But women do 2/3 of all the housework worldwide. They spend most of their time feeding, caring for the children, caring for the home, doing all of this work, and women own less than, I think it's less than 5% of land in the world is owned by women. In some countries, women still cannot own land. Women make 1/10 of the world's income. The other 90% is owned by men. But why does this matter? Well, as soon as women start becoming educated and start having more job opportunities, they start having fewer children for a variety of reasons. Usually because they go to school longer, they're not having children at 14. So they're in school up until they're 18, 20, 22, 25, whatever. And that means that they've lost some of those childbearing years, so they don't tend to have as many children. They go out and they get jobs and they're able to support their families. So they do not have as many children, in part because sometimes your jobs don't have very friendly maternity leave policies. We find that illiterate poor women have 5 to 7 children. Literate poor women have 2 children. Just having literacy decreases the number of children they have, on average. Part of that has to do with then understanding your own medical care and your own fertility options. But it also has a lot to do with in countries where we have started a micro lending, in countries where they've started doing microloans, women seem to be the people that take these loans and do the most with them. A microloan is something like a loan of a couple $1,000, maybe even a couple $100 for somebody in a developing nation to start a company. They will then pay that money back. It's usually not going to come from a bank. It's going to come from an individual or a missions organization that partners with them, or from a business that works in that area that gives them a micro loan. We find that women repay microloans at a rate of 95%. And they reinvest the money that they make in education, clean water, agriculture, and childcare for their community. And they tend to be pretty successful with the microloans. And in these communities, the men also are very successful with their microloans. They're less likely to reinvest the community in childcare and education, but the women are likely to do that. And many of the reasons they have this ability are that they then feel that they have the choice of whether or not to have children. Because in some countries, women do not have the right to tell their husband they don't want any more children. In Bangladesh, educating women took the poverty rate from 74% to 40%, educating them and allowing microloans. Did it change their population size? Maybe not. But it has allowed them to have more money, more resources, more use of things. Okay, so one of the problems that an increase in human population brings is increased poverty in some areas. Maybe not every area of the world, but lots of areas are having problems with poverty. And most countries, if not all countries, have people that are going to be living far below the poverty line. Poverty is usually defined as not having, usually a monetary limit. When we think of people that are in poverty, we think of people that don't have enough to cover their daily needs. This might include food, which is usually where we think about things. But it could include not having enough money to pay for electricity and water. This might mean not having enough money to buy clothing or firewood, or to not even have a place to live. So we can define it a multitude of different ways depending upon how you want to look at poverty. But it is a problem for people. None of us want to have, or none of us want to find ourselves in a situation where we don't have enough to cover our needs, but people find this every day. We find that people who are living in poverty shockingly tend to have pretty high environmental impacts. You wouldn't expect that, but they do. Part of it is how you're probably going to buy things that are cheaper items, which tend to be things that are more disposable. The clothing might not last as long. The things that you purchase will not be good for as long a period of time because they're not made to last. It's a byproduct of living in a community that sees goods as disposable, and those are the goods that we unfortunately make a lot cheaper. We also find that people living in poverty tend to have a higher birth rate than people not living in poverty. Multitude of reasons why. It may be linked to lack of literacy, lack of knowledge about being able to not have as many children, or it could also be related to the idea of one of these children may be able to support me, and having more children in order to support our family will be good for all of us in this family. So children may be seen as a way out of poverty, and they very well could be. If we're concerned about poverty as it relates to an increasing human population, though, reducing poverty is important. Because if you reduce poverty, we see that it actually reduces the birth rate, but also increases the quality of life for people. So reducing poverty has a very big benefit to those that are dealing with it. About 42% of pregnancies in less developed countries are unplanned. And actually, we're now seeing in the United States, it's probably pretty similar. Greater than 30% of pregnancies are unplanned. And if you were to ask, in a recent survey, somebody asked the concept of not, were you thinking about having another child, including planning, but where people were just not actively trying to get pregnant. It was more than 75% of pregnancies in one form or another may not have been entirely planned. Okay, well, there's a lot of reasons why. Family planning is not available, people don't take advantage of it, people don't believe in using it. But in countries where poverty is an issue and there's high rates of birth rates, usually also high rates of infant mortality and of women dying in childbirth. They also find that in areas where you make family planning resources available, there is a reduction in the number of abortions that are done because people have the opportunity to not get pregnant and then have an abortion because they don't want the child. I think it's a very cold scientific way of talking about it, but it's how it's talked about in literature. How do you think reducing poverty, though, is going to impact the use of resources? It might increase it, but do you think it will? If suddenly no one was living below the poverty line and everybody had enough money to meet all of their daily needs, do you think we would use more resources or fewer resources? How so?
Well, people in the United States would have the money to afford not only what they need but what they want already abuse that power. So we're giving that ability to more people, and they may or may not abuse it.
If no one's going to be starving, there's going to be a lot more food needed. So we're going to need a lot more areas for farming, a lot more clean water needed, so a lot more use of clean water. And yeah, as soon as suddenly you can afford all the things that become necessities, more and more things become necessities. And then everybody has a car and everybody drives everywhere. But we're going to see us talk about urbanization. Maybe there's ways that we could do this better in the cities, where we could actually spread out the use of resources over a larger number of people. And it is possible if we start to rethink how we live our daily lives. How many of you live at home, find your home less than 5 miles from Eastern? Not a single one of you. Anybody less than 25 miles? So just Tasha and me, and Sarah. Anyone more than 500 miles? Okay. Wouldn't it be great if we had some sort of a system that allowed for people to get where they needed to go that was a little bit more reliable and faster than public transit? I live about 15 miles from Eastern. If I were to do public transit, it would take me about 3 hours to get here, because I have to go completely into the city and then completely back out of the city, because even though I live in Delaware County and you would expect that SEPTA would be able to get me from my house to here, it cannot without taking me into Center City and back out. And on a day like today, well, that might have been faster than following the salt trucks at 476. In Thailand, they have worked a lot on raising their standard of living and reducing the number of people in poverty. They have seen it related to a reduction in birth rate, but the big thing they have noticed is that as they reduce poverty, there was a massive increase in literacy rate, in government support of literacy programs and educational programs, and that was allowing people to think about the choices that they made with resource consumption and other things. But they had to put governmental support behind literacy and education and reducing poverty in order to get any of that result. That it's not just something that you can do on an individual level. There needs to be some sort of systematic support. What are these? Solar panels. Can any of you live for 24 hours without electricity, do you think? You could go a week? A week in the middle of the winter? Maybe not. Or a week in the middle of the summer might even be harder. 90-degree days, lots of humidity. Solar cells, we're discovering, can be installed in areas and allow people ready access to electricity. Perhaps not entirely all the electricity you might want to do things, but they're being installed by different companies throughout Africa. Does anyone know which company went into Puerto Rico to install solar cells on the hospitals? It's a car company you might all want to own a car from someday.
Tesla.
Mm-hmm. They went in and they paid for the construction of solar cells to help power some of the hospitals in Puerto Rico to get them back on the grid,
because they thought it was wrong that hospitals didn't have electricity. How could you help people without it? Same with some of the schools, they were concerned about that. We're finding that solar cells are relatively cheap to construct if you have all of the supplies you need on hand. But deploying them is problematic. You have to have support. You have to have somebody willing to sponsor it usually. And one of the bigger problems with getting electricity to areas that don't have nuclear power plants, electrical generating units, is you have no grid built in. So you have to build the electrical grid. You have to build the supply lines to them. But if instead we can just plant small wind farms or solar panel farms in areas where people can generate electricity, they can have resources available to them and they can have electricity. Brings up an interesting point. Maybe we can have more people and get people out of poverty and help them get things without actually utilizing more oil and more coal and more nuclear power. Maybe there are ways to do this. We just have to think outside the box. India and China are the two countries we're going to look at for how they've attempted to reduce their population growth, because both have tried. And India, well, they started doing a family planning program in 1952. It wasn't successful. From 1952 to 2012, they went from a population of 400 million to 1.2 billion. It's a pretty big increase in population in 60 years, more than doubled their population. Their annual growth rates during that time were between 5 and 18 million people more every year. More people, more supplies, more abuse of the environment potentially, more resources utilized. But also it meant that they might not have had enough schools. They didn't have enough jobs for people. They didn't have enough places for people to live. All of the things that are linked to poverty, they didn't have enough of the things ready and able to support the growing community. Looked at why didn't it succeed? Well, they didn't plan very well. There wasn't enough governmental support for this to work, and it was relatively ineffective in the support that they had. Less than half of the people in the country were willing to use any form of birth control, even though 90% of them had birth control readily available to them. Some people don't believe in the use of birth control, so they would not use it on grounds related to religion or perhaps ethical concerns. We think the main reason is related to the low status of women. If they had multiple daughters, they would continue having children until they had enough sons to carry on the family name and to bring enough prominence to the family, because male heirs were important. Having more children also demonstrated how virile the man was and how healthy he was and his status. So you cannot, in a culture that values having lots of children, come in and say, okay, well, here's some condoms, here's some birth control pills, just don't have as many children now, okay? Because that doesn't work. You've taken away the very nature and the importance of having a large family, and you're not taking into consideration what the cultural concerns are. And they did it differently. They had a rapidly growing population in the 60s. They had a famine in the late 1950s through the early 60s. I think it was 58 to 62. 30 million people died during that famine. They realized they could not continue having their population growing as it was. They didn't really know what to do, but by the late 70s, in the early 70s, they started promoting this one-child family plan. By the late 70s, it was named the State Birth Planning Commission, and there were governmental benefits to only having one children, like more food, free healthcare, better jobs, a salary bonus to the working parents. And when that was not enough, what did you think they tried instead? Free to go there. In 2016, starting on January 1st, 2016, they changed their mind. Every couple is now allowed 2 children. I did post the article to Brightspace about this in case you were interested in reading it. Why do you think they were allowed 2 children? They decided this was for balanced growth of the population, was the word from their planning committee. This is 100 million couples that were now allowed to have at least one more child with this affected, that we knew of off the bat. In January 2014, they had started allowing a few couples to have a second baby, but only if both the mother and the father were an only child. And then they relaxed it a little bit, and then it was if one of them is an only child. Because in 2015, they realized that they had put this so much into their culture and their identity that having one child was the way to do things, that people, when given the opportunity, didn't want to have more than one child. That they had seen that as something that they should not do. So in 2015, when this was still not catching on, they decided they were going to open it up that every couple could have 2 children. This is their way of still being committed to population control, because 2 children is the replacement rate for a couple, if you want to look at it from that perspective. But in the next 15 years, they will have 400 million people over the age of 60 living in China. They will have the most elderly population on the planet, percentage-wise. And they won't have as many people to care for them as they otherwise would. And then a study came out that found that China's fertility rate had started dropping on its own and would have dropped to levels of about 2 children per family in the 1980s had they not even instituted this policy. So this policy that probably seems to most of you kind of barbaric, the idea of forcing people to have one child, to potentially sterilize people, force them to have abortions if they were having more and more children, to penalize them for having more children, or to pay a bonus to people that only had one. This policy that is very much anti-family wasn't even necessary. And probably they could have had the same result from doing nothing. Except they wouldn't have quite as elderly of a population, and they would have enough women to marry off to their men. So this policy that led to the abortions of many women and the adoption of Chinese women outside of the country could have been entirely short-circuited if they'd have thought ahead about how their population was already handling childbirth concerns. Any of your thoughts on these things as policies of regulating how many children people have? Do you think it's wrong? You okay with it? Do you want to say, like, okay, we can say people can't have any more than like 15 children? Like, is there a limit? Should there be a limit?
I think the limit needs to be between government and family, that they don't say something.
That they don't say any, that how many children you have is the direct result of your family.
Yeah, I don't think it should be so controlled from a government perspective. Like, I think that's infringing on the human right. Well, actually, I don't know what I think about the right to reproduce, but I do think there's some sense you should be able to have children without being told how many. But I actually do think it would be good to have cultural, like, I think it's interesting to think about the cultural shift to where they thought, like, having more children is bad. I don't think that we should have that view, but where maybe if there were cultural shifts, and I think there already are, that like having a smaller family is more normal, I think that could be good for population, but how to do that in a way that isn't anti-family is hard. So I don't know, maybe if, you know, if you talk about the carbon footprint of every person, and then when you're having children, you think about that, you know, that could be something that is more like normal for people to think about culturally, and that would be good.
Does anyone come from a very large family? How many siblings?
Well, there's 5 plus other generations.
Oh, that's not so bad.
No,
I'm thinking more of like, I knew a family growing up where they had 12 children
I have cousins that
in a 3-bedroom house. And at one point in time, the youngest child was well, it's still true. The youngest child that the couple had was younger than the child that their oldest child had.
Some longevity.
They had a lot of children in a 3-bedroom house. And people frequently said to them, well, that's not fair. You don't have enough space for your kids. You don't have enough this. They don't get enough like attention from you. And how are they ever going to succeed in like life? And how are you going to pay for them to go to college? That is not a really helpful way to talk about it. Because their answer was, we have our children. We love them. We always wanted to have a lot of children, and we do. And we can afford to put money on the table, or money for food on the table every night. We can pay all of our bills. If they want to go to college, they can take out loans, and that's just how it is. But they always wanted a lot of children, and they had them. Now they have a whole lot of grandchildren. Equally, we have to be sure that we support people who don't want to have any children. There needs to be a way for that to also work. And that's where this Social Security net and things were supposed to kick in. But in a lot of countries, what we're finding is as you have an aging population that's getting older and you have a smaller population underneath that's going to support them, that there. Oh, this one is difficult for human population concerns. Environmental refugees. The reason it's difficult is because technically this category doesn't really exist. We think it should exist, but it doesn't really exist. Environmental refugees are people who leave their areas, leave where they're from, because environmental degradation has somehow destroyed their resources. We'll talk later in the semester about Lake Chad. The highlight, when we get to it, if you can call this a highlight, is that it is shrunk over 90% in an area of Africa where there's not enough fresh water already to begin with. So we have people having to leave the areas where they're from because they don't have water, or maybe because of sea level rise, or because of flooding or drought, that somehow they're separated from their resources. In other instances, they're leaving because they're not only war refugees, they're also environmental refugees if war has cut them off from their resources. We expect that by 2050, 40% of the world's population will be affected by drought, by significant drought. The UN has not yet included environmental refugees as a refugee group type. The UN does have different types of refugees they recognize as having refugee status, which allows them entry into other countries and it allows them other sorts of support. Environmental refugees still haven't met the threshold. They are counted as either displaced persons, destitute migrants, or some other category. So we need to find a way for the UN to recognize them as refugee status if they're going to get the same benefits that refugees get from war or from other disasters. None of you have to do this. What's happening in this picture?
People are traveling to a common water source so they can collect as much water for maybe a day and then walk however many miles back to where they live.
We don't have to do this anywhere in the US right now. Well, that's probably not true. I imagine there are actually still places in Appalachia. I know there's still places in the Appalachian Mountains that still don't have indoor plumbing. There's some areas that still don't in the US. But as a group, very few of us have to do this. How would your life be different if you had to carry all of the water that you needed? Let's say we had to walk to King of Prussia Mall, get all the water that we were going to need for the day, and then bring it back.
It's like half the day you spend.
Half your day is spent getting water. There goes all of your nap time, all of your study time, all of your other things. We need to find a way to keep the population in the resources that they need. And we're going to see that there are ways to do this as we go through some of these issues this semester, but we need to think carefully about how to do it. And believe it or not, one of the ways that we can have more people in an area, more resources available to them, and potentially less of an impact on the resources is urbanization. Cities.